Hi, I'm Haria, and today I'm going to show you about my project. My project is basically Android based spy vehicle, and it's a combination of three fields. The first one is wireless, embedded and software. Now what my project exactly is, this kind of vehicle is based on Android phones. So any kind of handset which is Android enabled can move this vehicle. So you don't need to have any kind of remote controls in your hand. You just need to have an Android enabled handset. That's all. If you have that Android enabled handset, you can download my app and you can run this vehicle. That's that simple. It's that simple. Now apart from the feature of Android, I have connected a Wi-Fi module to my vehicle so that my vehicle can be extended to a range of about 100 meters when you are just sitting on a single place and moving your vehicle to 100 meters. Not just that, I have mounted a wireless transceiver camera onto my vehicle for spying purposes. As the name suggests, for my project, it's Android based spy vehicle, so it will spy the environment, it will spy the area, it will go into surveillance, it will capture the images through these cameras and will transmit it wirelessly through a transceiver unit and will be displayed on the laptop. So what you need to have is just a mobile phone in your hand and a laptop on your lap, and that's all. You can control the vehicle through your mobile phone, you can see the images on the laptop and make your vehicle free to move anywhere within the range of 100 meters. So that's what is my project is. I'll show you my hardware working model. Please have a look at it. Now this is my hardware, this is the Android based spy vehicle, this is my project. The heart of this project is PIC16 controller. It's got 5 ports, port A to port E. The basic idea for choosing this kind of PIC16 controller is that it's got 5 ports. It's quite beneficial. Port A has got an inbuilt analog to digital converter. So any kind of analog input coming to port A will be converted into digital. It's inbuilt analog digital converter. So the analog input, as a form of analog input, we have connected 2 sensors to it. The first sensor is NTC temperature sensor. It's a thermistor, and the second one is MQ6 gas sensor. The temperature sensor will sense the surrounding temperature and will convert that value and will give the analog form of output. This analog output is converted into a digital output by this port A section. The MQ6 gas sensor is an LPG sensor. Any kind of LPG leakages or butane or isobutane leakages will be sensed by this gas sensor in the analog form and will be converted to digital one. So both these values are wirelessly transmitted through this Wi-Fi module, as well as it's been displayed on this LCD. So this LCD is also interfaced with the PIC16 controller. The LCD is showing you the temperature as well as gas values. The temperature is about 33 degrees Celsius and gas is 36 parts per million. Now that was all about my port A of PIC16 section. Port B is interfaced with these motors of this vehicle. The port B output is basically an active low output. The active low output is being pulled up by this 10 kilo ohm ceramic resistors. The output of this ceramic resistor is being amplified by these individual transistors, and it's given to these relays. The 6 relays are driving these motors. I have connected 2 kinds of motors. The 4 motor, in total I have 5 motors. 4 motors have got 60 rpm rotation and 1 motor has got 5 rpm rotation. So the 4 motors are driving the wheels, and 1 motor which has got 5 rpm rotation is driving this kind of rack picker. So this rack picker will move up and down in a rotation in 5 rpm rotation. Now another port of PIC16 is port C. It's basically designed for serial communication. It's got 2 pins, C.6 and C.7. So C.6 is used for transmission, C.7 is used for reception, and I have the Wi-Fi module on the back panel of this vehicle. This is the Wi-Fi module. As you can see, the LED is blinking. The Wi-Fi module is on. Now this Wi-Fi module is getting connected to PIC16 controller through C.6 and C.7, which helps in serial communication. The serial communication is happening through 9600 baud rate. Now finally, I have connected the port D of this LCD, of this PIC controller to this LCD. the port D is connected to the LCD in 4-bit mode configuration, so that will send an 8-bit data or 1 byte in 2 steps or in 2 cycles. And again, the port D's pins, which is read, write, RS and enable, is connected to LCDs. So that's all about the hardware part of my project. Now I'll show you my software part of the project. The software part of the project is somewhat like this. This is the high link Wi-Fi module that my vehicle has. This vehicle has got a high link module. The Wi-Fi module is high link module, which is A53F. It's connected. It's showing the status connected. Now I'll show you the app that makes this vehicle move forward, backward, left, right, as well as the rack picker move. This is the app that controls my vehicle. First of all, you need to set up this app. It shows 2 IP addresses, work as client and work as server. The work as client has got an IP address. I just have to change it. It's 254. The work as server address is same. The port number is 8080 for both. The numbers which you can see 2, 3, 4, 1 are used for moving forward, backward, left, right, and 5 and 6 are for rack picking up and down, so that I have interfaced these numbers with the motion of my vehicle, and now I am connecting. It's showing the status connected to server. So now my vehicle is ready to move through the mobile phone. Now I am moving this vehicle. If I press above, the vehicle is moving forward. If I press back, the vehicle is moving backward. If I press right, the vehicle moves right. If I press left, the vehicle moves left. If I press D, it stops. Now for rack picker section, I have kept 2 buttons, which is A and B. For A, it moves downwards. For B, it moves upwards. So that's how. This is very simple. The configuration, the kind of graphic user interface is so designed that it fits compatible with the Wi-Fi module that I have connected, and you can control this vehicle through any mobile phone which has got this app. Now you can see on this vehicle is on the top of it is the wireless camera. This is a wireless transmitter unit. This is its antenna. This wireless camera will capture the surrounding images. This captured image will be transmitted through this antenna to the wireless receiver, which I have over this side. This is a wireless receiver. The wireless receiver has got this antenna. It will capture the images, and the captured images is displayed on this laptop. Basically, the output of this receiver is audio video output, which can be directly connected to the TVs. But since I have displayed it on the laptop, I need a TV tuner card for it. The TV tuner card will convert it into such a format that it can be displayed on the laptop. So now I am controlling my vehicle through this mobile phone. The vehicle is moving forward. The vehicle is moving backwards. It's moving on the right side. It's moving on the left side. It's stopped. Its rack picker is moving downwards, rack picker is moving upwards. So that's all about my project. So my project was all about Android based spy vehicle, which can be used for environmental surveillance and monitoring purposes, for spying purposes. You can use this app for moving this vehicle. Any kind of Android app, any mobile phone who's got Android operating system in it can download this app. It's available free on Play Store. The app's name is iTid Studio, and can configure this app with the Wi-Fi module. The moment it's been configured, the moment it's been connected, you can use this vehicle for driving over the range of about 100 meters just by sitting on one place. You can control this vehicle through this graphic user interface and can watch the videos that's been captured by this kind of wireless camera onto the laptop. So that was all about my project of Android based spy vehicle. I hope you enjoyed watching this video. Thank you for watching this video.